Okay, this is problem number 10 on section 2 of chapter 10. So for this problem, first thing we gotta do is set up the calculator and turn the diagnostic on. Let me show you how to do this. On the calculator, you need again to turn this option on, the diagnostic on. You have to do this only once. I mean, you don't have to do this in every single problem. Once you do it, it will stay on, and you don't have to worry about it. First of all, you gotta go to second 0. Okay, when you press second 0, this is the first step here. You will see this screen, and you gotta go all the way down, scroll down like that. Have to go like this with the arrow down here until you see the letter D. It goes in alphabetical order anyways. So you go down. You will see a menu of options. And I'm close, okay. Here, diagnostic on. Okay, so you wanna when you find this menu right here, this option, this one right here, you press enter. Press enter, and then okay, of course you have to press enter again. Okay, if you don't see this word that says done, it means it's not completed. So you need to press enter again. Okay, press enter twice. Okay. Okay, once you have it like that, that means your calculator is ready. So you don't have to do this again in each single problem. You only do it once and that's it. But this is important because if you don't do this, you will not get the correlation coefficient. So second step, you need to set up this table on L1 and L2. This table, you have done this before, and I'm pretty sure you know how to do this. You go to Start, you go to Edit, and you set up all these numbers, right? So you have next step is having this table set up on L1 and L2, and then you go to Calculate, right? Let's go to Start, and we move to the right side, the one that says Calculate, and number 4. We choose number 4. Here we click number 4. Okay. What you will see is this menu. It says X list. Make sure you have L1 there. Y list. Make sure you have L2 there. And for now, that's enough. That's enough. Let me go down here and hit calculate. I'll hit calculate. What you will see here is you have the coefficients of the linear relations. The coefficient, I mean the slope of the linear relationship is going to be the letter A. Okay, that's going to be 1.2 if you round it up to the first decimal place is right here. And the y-intercept in the letter B, the constant, is going to be 49.5. Okay, you remember that those classes from high school about the linear function. This A represents the slope and B the y-intercept. Okay, so that's what you write here on this part. The regression equation is this one. Okay, y hat equals 49.5 plus 1.2x. Okay, now the next part is you need to predict the value on the left arm, given that you have a 90 value of 90 millimeters of Hg on the right. So this is going to be on the independent, right? Independent, and you want to find the dependent. Well, in this case, we need to find out if there is a linear relationship here. So the question is here. The question is pretty much this: is this linear or not? Is this relation linear or not? If there is a linear relation, we use that equation right here. If it is not a linear relationship, we have to use the mean of all these numbers, So we need to find out if there is a linear relationship. Okay, so let's go so here on this part, on this icon, you gotta click here. Click here. What you will see is this table right here. This table. And we have to use a 5% significance level for our problem. Look, the information is right here. Use a 5%, here. Is a significance level of 5%, and we have 1, 2, 3, 4, 5 pairs. So we have 5 pairs and a 5% significance level. These are the critical values. Okay, so these critical values, we sketch a distribution like that, like a normal distribution. The null hypothesis states that there is no linear relationship right here. Look, that's a null hypothesis. We assume that there is no linear relationship. And the alternative hypothesis is that there is a linear relationship. And now this is a two-tailed test because we have the alternative hypothesis has this symbol. Okay, so it's pretty simple. The middle one, the middle part is nonlinear. Okay, the null hypothesis is nonlinear. We always assume that, and that number right here, the critical values, we place it here and here. Okay, minus and plus, right? 0.878 and negative 0.878 and positive 0.878. Okay. From our calculator, we obtain this correlation coefficient. Okay, this number right here, and this number right here falls in the nonlinear relationship. Okay, look, 0.821 is actually before this number. These are the critical values. Okay, these are the critical values. Like if you obtain something here, well, that'll be a linear relationship, but you you obtain this coefficient, so there is no linear relation. Okay, so what happens when you don't have a linear relation? Well, you don't have a linear relationship, you cannot use this equation right here, the one you obtain. That means this model is not a linear pattern. Okay, so what you have to do is take the mean of these numbers. As you know, the mean of those numbers, you can just add these numbers together and then divide it by 5. Okay, or you can do it on the calculator, right? I mean, easier. You want to do like that, stack. Then you go to calculate to the right side, and then you go to number 1, which is bars, and under list, be careful. You want the mean of this part of L2. So you gotta enter L2 by hitting second 2. Okay, see how you got L2 here on list. So if you go all the way down and press on calculate, okay, that's the 155.4 you get here. Okay, so something else. As I said before, you cannot just, add the numbers, right? Like 175 plus a 170 plus 143 plus 144 plus 145. Hit enter and divide all these by the number of elements, right? That's I think the simplest way to do it, right? The easiest way to do it. So that's how you do this problem. Okay.